Hi, I am Ignacio Cuirado, and I'm going to be talking about mesh estimation for abrupt deformations of textureless objects. Estimating deformations can be very useful for deformable object manipulation. However, some challenges may arise, especially when the assumption of deformations being slow and smooth cannot be longer applied. Some processes may be too fast compared to the sensor sampling frequency, and furthermore, some objects might lack the visual texture that allows to track points and therefore update the mesh, as in the example we see below in this method, where object texture is very rich and therefore updating the object mesh can be done with the use of visual texture. In our case, since we don't want to rely on texture and we want to be able to tackle fast deformations, we are using an elastic contour mapping that makes use of similar geometric features of the object's contour. Using this mapping between consecutive object states, what we do is we update the position of the nodes belonging to the object contour and simulate through this position update the rest of the nodes of the mesh, thus obtaining a deformation mesh for each time instant. In the results, what we did was basically comparing our method with a method that uses a homogeneous mapping between the contours. So in this example, the object is being stretched in a very short period of time. The homogeneous mapping does not update properly the nodes, as we can see on the bottom left, and this leads to a non-realistic deformation mesh. On the other hand, in this second example, only one part of the object is being deformed. The homogeneous mapping, what it does is basically it distributes the deformation all over the object contour, rather than noticing that the deformation just occurred in one part of the object's contour. So our method properly handles this. Thank you very much. Any questions, feel free to ask.